We can also think of whole numbers as fractions, equivalent fractions. Let's start with 1. If we have 1 and we think of it as a fraction, we're not actually cutting it into any more parts. So 1 is the number of parts we have, and the shaded part is 1. We want all of it. So we can express 1 as a fraction, 1 over 1. But we can also actually divide it into more parts. So this time we've actually got 4 equal parts, so our denominator is 4, and the shaded parts is 4 as well. So 1 is the same or equivalent to 4 quarters. How can we express 3 in quarters? We've seen how to express 1. Well, what if we do the same thing and we divide each of these rectangles into quarters or 4 parts? So there's 4 quarters, there's another 4 quarters, and there's another 4 quarters. So 3 is the same as or equivalent to 12 quarters. So if you were working on a problem and you needed 3 to be a fraction, with quarters, that's what you could do. Now let's leave those there for a moment. We can also express our 3 whole in eighths. We've got 8 eighths, another 8 eighths, and another 8 eighths. So 3 is actually equal to 12 quarters as well as 24 eighths. Now 12 quarters equals 3, and 12 divided by 4 equals 3, and that shows us just how much division and fractions are related. This helps us see how fractions is like division. 12 divided by 4 is also 3. So when you see a numerator and a denominator, you can actually think of it as division as well. Why don't we see 12 divided by 4 and see how it's the same as the answer with fractions? Let's think of 12. If we have 12 things to share, let's just use squares here, and we want to share them into 4 equal groups. One of the groups has 3 in it, so 12 divided by 4 equals 3, and 12 quarters equals 3. Now why don't we think of it as a fraction this time? If we see 12 over 4, we know that it is 12 divided by 4, but if we're working with fractions, it would be good to see it as well. Let's think of 12 as our whole. When we have a denominator, that's how many equal parts we actually break our whole into. So we could think of each part separately. 12 squares broken into quarters, so we could break each one into quarters. Now the shaded part, the numerator, tells us how many of those quarters we actually want. We've got lots of quarters, but we only want 12. And you can see when we have 12 quarters, we've actually got 3 whole squares. So 12 quarters is the same as 3 whole squares. So 12 divided by 4 is also equal to 3. So we can see that division and fractions are closely related.